Looking at combining like terms here, our standard for what we're talking about right now is solve linear equations in one variable. I can, down here, combine like terms and then solve equations that are going to require us to combine like terms. So first of all, a definition. Like terms are terms whose variables and their exponents, such as the 2 in x squared right here, are the same. So for example, 7x and 2x, they're like terms because both of their variables are x. So notice I've got 7x right here, I've got 2x right here, they're the exact same. So if I were adding those together, for example, I would have 9x because I would have 7 of them represented here and 2 more right here. But 7x and 7x squared are not like terms because this one just has a variable of x. This has a variable of x squared, and so those are different. Another example of not like terms might be something like this. 7x and 2g. Notice that x is my variable for this, and g is my other variable, and so these are not like terms, and I cannot combine them. So another example, I know this is kind of a goofy smiley face here, but I've got some limes, I've got a lemon, and I've got some oranges. So if I was talking about combining like terms here, I notice that, oh, I've got 2 limes. Okay, 2 total limes. If I look at my oranges down here, I've got 6 oranges. If I could spell oranges. Okay, but I can't combine these two things because they're not the same. Limes are not the same as oranges. If I tried to combine them, I would have something like a lime orange, and that doesn't make much sense to us. So think about pieces that are terms with it when they have variables and see if you can combine them or not. So what I do for combining like terms is I start with my variable. So I start with variable, and I'm looking for variable terms. So when I start here with the first one, it says 6. That does not have a variable with it, so I'm going to move on. I go to my next term, 3x. That does have a variable with it, and so I'm going to put a box around that. And then I go to 10 over here, no variable, and so I know that my first chunk right here is going to be what was in the box, just a normal 3x. Okay, now I'm looking at what's left. I've got a positive 6, and I've got plus 10. I'm just following what the signs tell me to do. I've got positive 6 plus 10, so that's going to be plus 16. And I have combined my like terms here because I've taken all the pieces that were the same and I've combined them together following the operation that it tells me to use. Okay, so again, I'm going to start with my variables. I start and I go term by term. So 9j, yep, sure enough, that does have a variable. And then I wrote over that there, so let's erase that here for a second. Okay, I've got 9j. Let me go over far enough there. Kind of wrote over it again. I look at my second term. Oh, plus 7j. I've got another one. So what I'm doing here is I'm putting a box around the operation also because that's going to tell me what I need to do with those terms. The next term, this minus 5, no variable, so I'm going to hold off on that for right now. So right now I'm just looking at the terms that are in the box. So 9j plus 7j. I'm just combining those like I normally would. 16j, I'm adding those. The only piece that's left here is a minus 5. And so I have combined my like terms by putting the like pieces together, the terms with the variables, and then just my numbers. Okay, one more example. I want you to try this one on your own first, and then we'll hit pause. And so hit pause now, try it on your own, and then when you're ready to see the answer, go ahead and hit play. Okay, so I've got some variable terms here. I've got the 19w, and over here I've got a negative 3w. Okay, so I'm going to follow what the terms here tell me to do. 19w minus 3w is going to be 16w. And then inside of those boxes, I just have 2 numbers. I've got positive 13 minus 9. So positive 13 minus 9, when I look at combining those two, it's going to leave me with plus 4. So you should have gotten 16w plus 4. Again, I'm just following what the signs of the numbers tell me. Okay, another one here. I'm going to combine like terms. I want you to go ahead and hit pause, do this problem, and when you're ready to check your answer, hit play. So I'm going to go ahead and put a box around my terms with variables, and notice I'm including the sign that goes with it. And so now I've got 3 terms in my boxes here that are all like terms, and so I need to combine them all together. So I've got negative 10b plus 7b. So I've got more negatives here than positives. So more negatives than positives, that's going to leave me with negative 3b. And then I still have this term up here, which I am going to combine with now. So negative 3b minus 2 more b is going to leave me with, negative 5b. I've got my next pieces here are just my numbers. So I've got positive 3 and I've got negative 8. Notice that I've got more negatives in here than positives. In fact, I have 5 more negatives than positives. And so after combining my like terms, I have negative 5b minus 5 more. So now we can talk about solving equations that require combining like terms first. So the thing that we have to remember here is we have this equals sign, and this equals sign is kind of like this barrier. So I can do things to this side of the equation in terms of simplifying, and I can do things to this side of the equation in terms of simplifying before I start to solve. So if I need to combine some like terms over here, it doesn't change anything that I'm going to do in terms of solving. I'm just simply combining like terms. So I've got 3x plus 2x. I'm going to take care of that first. Those are my variables, and now I have 5x. The plus 6 is left, equals 21. So all I did was I combined some like terms on the left side of my equal sign right here. Everything else has stayed the same. Now notice I just have a 2-step equation that we've been working on that we can practice here. So here's my variable. I want to get that all by itself. So I better get that 6 out of there. These 6's are going to cancel. I now have 5x equals 15. I now have multiplication, and I'm trying to get x by itself, so I better cancel out that multiplication and make this number be a 1 so that I have just 1x equals, and then when I do that division, I get 3. Okay? So here's an example here of a word problem. Tyler can do P number of pull-ups and Ryan can do 5 more than Tyler. Together they can do 85 pull-ups. How many pull-ups can Ryan do? So let's kind of take a look at this. If Tyler can do P amount, okay, and Ryan can do 5 more than him, I've got the amount that Tyler can do, I've got the amount that Ryan can do, and total it said together they can do 85. Okay, so it says how many, this is, we can kind of label this. This is Tyler plus Ryan equals total. Okay, and so now I can take a look at my like terms here. I've got P plus P, and then I've got this plus 5 left. So P plus P is just 2P plus 5 equals 85, and now I can solve my equation. And 2P is going to equal 80. Divide. P is going to equal 40. So the amount of pull-ups that Tyler can do is 40. But I was asked how many can Ryan do. So once I get this number of 40, I need to think about, oh, can I plug it back in? And Ryan can do 5 more than what Tyler can do. So Ryan can do 45 pull-ups. Okay, so here's just an example of where we're combining like terms in a story problem before we start to solve. Okay, go ahead and take a look at that and let me know what questions you might have, and we'll go forward from there.